Lecture 11.
Today then we'll do the muscles of the appendicular system or the appendices, and that will finish the anatomical part of the muscle, and then the next two lectures will be on this exam or about the cytatory membranes and rest extension lac potential, which are really important to understand before we get in the nervous system. So, and that will get us up to the Unit 2 exam. Have the eye clicker questions at the beginning today, and the last opportunity to look at your Unit 1 exam will be after class in the room. Oh, I got it again. It's LA. I keep doing that. This should be LA 124. Right behind us here. Okay. So, first eye clicker question, if you're ready. Where does it go? There we go. Which of the following is a connective tissue membrane surrounding a muscle fascicle? So, the membrane that surrounds the fascicle itself. Okay, go to about 5 more seconds or so. That should be everybody. Okay, let's see what you did. And looks like almost everybody agrees it's the last one, which is paramysium. The endomysium surrounds the cell, the epimysium surrounds the whole muscle, and each fascicle is surrounded by a paramysium. Okay, number 2. The buccinator muscle is which of the ones with the little arrows pointing to them? Buccinator. People say buccinator too. I've heard both terms used. Okay. I think it was 131 I had last time, wasn't it? Oh, that's 132. Okay, 5 seconds. This should be everybody. And looks like almost 100% again. Yeah, all but three people disagreed with you guys. But you're right, it's the one that the trumpet players use. I gave the example of hitting high notes. Number 3, the velocity of skeletal muscle contraction. Okay, a couple more seconds. You want to log in. 5 seconds. Okay, there's 2 people that have them. I'm going to stop it. Okay, and a little bit of disagreement there. Varies inversely with resting length. If anything, it would get really, there's no, the length-tension relationship is complex, to say the least, and it would never be one direction. It could go up and then back down, but there's no given relationship of velocity to length. That's usually isometric. Is constant in any given muscle. Only the Vmax is constant. That's probably what a lot of people thought about. There is a Vmax that's constant, but not the velocity at any one weight. Is inversely related to isotonic load. That is correct. Remember, the slope is a negative slope. Best studied only in, it can be only said in isotonic preparation, and if anything, it'd be directly related to motor size. So C is the correct answer. Number 4. Okay, connects muscle to muscle. There's another pretty easy question, hopefully. Okay, about 5, 4, 3, 2, 1. And wow, everybody agreed, and it is an aponeurosis, so A is correct. And the last one, you know, I have to have one interesting question. I hit missed stop, huh? Okay. Okay, that's plenty long, I guess. 5, 4, 3, 2, 1.
Everybody logged in? Okay. Looks like the responses are fairly scattered. I've done this experiment myself. Sapsagarbin is a plant extract which does very selectively inhibit only the calcium ATPase as part of the SR. And this is one of those relative import questions that I love. In other words, what's most important? Well, if you give sapsagarbin over hours, you'll deplete the calcium in the SR, but it takes a long time. And it's a relativity question. In other words, we're going to have lots of these in the next coming section when we talk about what's relatively important as far as resting potential and act potential. It turns out that the SR just stores an ungodly amount of calcium as far as how much is released. And it would take days to deplete it after giving sapsagarbin. What it does do, though, is very significantly prolong the action potential because you release it and then it takes forever to pull it back up. So the twitch is prolonged tremendously. So by far the best answer is D. But definitely you could think maybe you'd have muscular weaknesses if you didn't trap it. And you could say it'd be more excitable if you left the calcium out. But D is the correct answer. It's kind of interesting. Okay. Looks like I got you upset with that. Okay, so we're moving along and talking about the muscles that move the appendices. I can have your attention. The first one is the trapezius, the traps that the weightlifters call them. And the picture there on the top, it looks like a trapezoid is a complex shaped structure, but it has two parallel sides, which it doesn't really look like this does. I don't know how it got to be called a trapezius, but it's this triangular shaped, complex shaped muscle on the upper back. And it's an interesting story. It elevates the pectoral girdle, that's the scapula, and the clavicle, and depresses and adducts. Adducts means it brings it in. That can be pictured. But what about elevates and depresses? What this is kind of an interesting story. How can one muscle do two opposite things? Well, part of the story is it depends on the action, what other muscles are being contracted at the same time. And more importantly, this is a very complex shaped muscle, and we do have the capability of contracting a given part of it, not the other. So if you contracted this part, you'd elevate the scapula, and you contracted the more inferior part, you depressed it. So we often think of muscles as being like the biceps and having only one type of motility they're capable of. This is an interesting muscle that in itself can have antagonistic activity depending on what part of it you excite. Flexor on the shoulder is a pectoralis major, which is right here, this large muscle on your chest. Flexes the shoulder or brings the shoulder in. Very large muscle and also a favorite of weightlifters building it up. Lats or latissimus dorsi is this large flat muscle on the lower back right here, and it is an extensor, which means that it extends the shoulder, pulls the shoulder back, if you will, and adducts or brings the arm down. So that's this large latissimus dorsi. The deltoid is, I think, one of the coolest looking muscles, and I always think of the deltoid as looking like a delta, like the Mississippi Delta, like the rivers left this sediment out into the large lake or whatever. So it's triangular kind of delta-shaped muscle, very large, and it's a abductor, which means, of course, it's capable of moving the arm away from the body, and that's the deltoid. Okay, then muscles that move the lower arm, and again, I'm just picking a few muscles here and there to concentrate on rather than have you learn every muscle, because these are significant muscles we'll be referring to in other areas, but we don't have to learn at this time. There's no purpose in memorizing every muscle of the body. The biceps brachii are right here, and you see they have two origins, so hence the term biceps, and they flex the arm at the elbow, which you can easily see how they do if you just looked at the biceps. And the brachialis does the same thing. It's a synergist. The brachialis is in the synergist family, and it's right underneath the biceps brachii. You can just see a little bit of it underneath the muscle, so it parallels, and there's a synergistic flexor. And the brachioradialis, although down here, still is capable, or still flexes the lower arm at the elbow. So all of these do the same thing, so they're synergists. The extensors would open up that angle or extend the lower arm, and they're on the opposite side of the arm, as you'd expect, on the dorsal aspect of the arm. So the triceps brachii is a major one, and in fact the only one that I have on the list. There are some that are not quite so important. We always have the students learn these two quite prominent rotators of the arm. The supinator is on the lateral side of the arm, so on the thumb side. Once again, we always anatomically look at a human with the thumb outward, so that would make the supinator on the lateral side, and it rotates the arm so the thumb is up. And then the opposite, the pronator teres, which is right here, is on the medial side and rotates the arm so the thumb is now down, or pointed posterior, if you will. Those are very prominent muscles, and you'll be looking at them in lab, or have already looked at them in lab this week. Muscles of the lower arm, there's piles of them, and for our purpose in the lecture, they may have you learn some of them in the lab, but I'm not going to worry about that. Okay, then the muscles of the leg, we'll start out with the posterior group. One of my favorites, the gluteus maximus, huge muscle on the posterior. It is responsible for extending the thigh, we say, of the leg. So when we rise from sitting to standing, that's when the muscle which we recruit, and obviously it has to be quite large. So anyway, it's a very massive muscle that's a extensor of the thigh. The gluteus medius is underneath, and so they've dissected or ligated the gluteus maximus, and underneath there is a gluteus medius, and it adducts and rotates the thigh. And the gluteus minimus is right under it, and completely masked. Yeah, you have to just kind of layer these, and it does the exact same thing as the medius. So since it's abducting, it's bringing the legs inward, of course. The lateral group on the side of the leg is an interesting muscle. So this is a large fascia that goes across the lateral side of your leg, and there's a very small muscle that kind of puts tension on it, and it has a great name, tensor fasciae lati. So it literally pulls or holds the leg in, but it's also abducts in a way. And finally, the medial group on the inside of the leg and the inside of the thigh, there's some very nice cluster of muscles that are quite large. The adductor magnus is a large muscle that's underneath the gracilis, but it's right here. It's an adductor, pulls the leg inward. The adductor longus is over on the other side of the gracilis, and it's the only difference is they both insert, and origin is very similar, but it's a long strap-like muscle where the magnus is more triangular in shape. And you can't see it, but the adductor brevis is underneath those two. So there's a layer of three large muscles that all function to adduct the leg. And the gracilis is this I always think of the name graceful, but it's this large, long muscle that's on top of these three that's also an adductor. So there are 4 large adductors for this purpose. And then on the anterior side of the leg, there's a very large cluster of muscles that are called quadriceps. And there are 4 that are worked together as a family. The rectus femoris extends the leg at the knee, and it's this large, most anterior muscle right here. And then on each side of it, there's a vastus lateralis on the lateral side over here, and a vastus medialis. All of them extend the leg at the knee, so they're all extensors. So rectus femoris is in the center, vastus lateralis, and vastus medialis. And it's a quadriceps, so you know that there has to be 4. And it turns out underneath these 3, and if you cut away the rectus femoris, you'll see another one called the vastus intermedius. So there's 4 very large muscles that are flexors or extensors that extend the leg at the knee. So again, this would aid in running and standing and so forth to extend the leg. Across there's a strap-like muscle that extends across all of these called the sartorius, and I think different names mean different things to me. It's how I remember it, but I think a sartorial splendor, a magnificent muscle that waves across the front of the thigh. But anyway, yeah, it's another member of this anterior group to extend the leg. Okay, and then there's muscles of the lower thigh, and these are the medial view of the right thigh is where these are located at. And the flexors are the biceps femoris, which is just, you can barely see it, just goes through the back here. Then the semitendinosus and the semimembranosus. So the semitendinosus is right here, just anterior to the biceps femoris, and the semimembranosus is underneath it. So these are, again, kind of layered muscles, the biceps and the semitendinosus and the semimembranosus, and they're all flexors. They decrease the angle of the knee. Okay. And then finally, I'm going to get really done really fast. This is very no lecture, should it? Finally, we're going to get to the muscles that move the foot and the ankle, and we do have you learn a few of these, and we define plantar flexion and dorsiflexion. Dorsi means the dorsal side angle is decreasing, and this the kind of decreasing the angle at the heel side. Tibialis anterior is a dorsal flexor, and that makes sense because it would have to be on the anterior side of the leg, and that brings the foot up when you're standing, when you want to maybe kick a football or something. I don't know what you want to do, but anyway, that's tibialis anterior. Extensor digitorum longus is right below the tibialis anterior, and again, this, like so many other things, they're layered in another muscle that does the exact same thing. And then the plantar flexors, these do the opposite thing. They move the foot down, the toe down, and these are very large in people that ride bicycles because most of the pedaling is pushing the pedal down by twisting the foot in that direction. And so long runners and bicyclists have these large thighs, lower legs, and the first is a soleus, and that's shown right here, but it is underneath the very large gastroc, and the gastrocnemius is right here. The soleus, they cut away here. You can kind of see it underneath the gastroc indicated here. So the gastroc is this very large muscle in the calf, and then right underneath there is another actually quite large muscle, the soleus, and these two, see, they're very large, allow us to stand up on our toes or run or bicycle ride, and they get quite large calves, people that do that a long time. The gastroc connects to the calcaneus or the heel by an important tendon called the Achilles tendon, or the calcaneal tendon. So this tendon right here is very strong, and that's the famous Achilles tendon that hooks the gastrocnemius to the calcaneus. Also, he had a couple of muscles to turn the foot. The inversion is easy to remember. Turning the toe inward and turning it outward is eversion. And the eversion is would be on the lateral side, and you have the fibularis longus and fibularis brevis, and they make sense. They're right on top of each other. One is long and extends the whole length of the lateral side, and just underneath there is a short one, and they're pretty easy to remember. We used to call them, I don't know why, the peroneus longus and the peroneus brevis, but about 8-10 years ago they changed it to the fibularis because it's beside the fibula. But anyway, it's easy to remember that way. But anyway, they're on the lateral side, and there's a long one and a short one, and they are everters. And then the plantar flexors are the flexor digitorum longus, which is right here, quite long. It extends almost from the whole length of the tibia. And the tibialis posterior is just below that.